Okay, Assalamualaikum and good afternoon. Welcome back. Selamat Hari Raya. Macam mana Raya, okey ke? Merayakan ke?
Selamat Hari Raya, sir.
Raya.
Terkejut raya sah.
Terkejut Raya Bukan kau je, aku pun terkejut. Selingan. Before we start kan. Tiba-tiba start ni tak ice breaking kan. Lama tak berhadapan dengan cuti yang lama ni. So saya just nak share. Sorry siapa tu? Oh tak ada. Ini tak ada. Okay. Saya pun ada kejutan pada hari tersebut, which is the Sunday night. Actually yang keluar result tu kan, dia punya pengumuman tu Ahad malam. I think around 8 something lah. So at the time I was still in Pekan, dengan keadaan tak packing apa. Baju semua tak packing. Baju apa kosong kotak. Lepas tu ada member duk main troll kan. Saya ingat troll lah kan. Ingat kelakar lah kan. Sebab saya tak tengok sebab tengah mengemas rumah semua kan. Kita ada kucing semua kan. So tengah mengemas tu tiba ada kata besok raya kan. So ni kelakar ke? Janganlah buat kelakar kan. Sekali buka-buka, besok raya betul kan. Pukul 8 lebih kan. When kan aku tak kemas barang apa semua, tak buat apa. Dengan tak gosok baju kan. Tapi sebab saya balik KL lah. So bila balik KL ni tak jauh sangat kan. Sekejap lah besok. So lepas kejadian tu, sebab besok dah raya, aku dah plan raya, sembahyang raya semua kan. So at the end, bungkus ke rumah sempat lagi. Pukul 12.45 malam barulah saya gerak ke KL. Sampai dah 3.30 lah. Sebab aku tak terbaring tengah jalan kan. Sebab mengantuk gila. Tak tidur satu hari. Duk mengemas kan. So saya harap tak ada orang macam saya lah hari tu kan. Mungkin terkejut kot, awalnya raya. Macam tu lah. Kita dapat nampak anak bulan kan. Biasa anak bulan semua tak nampak, dilitupi oleh awan. Tapi kali ni rezeki kita 2 tempat, saya lah 2 tempat yang nampak anak bulan. Sebab itulah terus bila nampak anak bulan tu, maka Syawal lah. Itu yang terus mengejut tu. Begitulah. Saya ingat saya seorang yang terkejut buruk, ramai agak terkejut buruk kan. Tapi okey lah kan, raya tambah 1 hari kan, cuti kan. Okey lah tu. Okey, sekian selingan. So saya harap semua dah berayakan. Kalau tengok kes COVID pun, saya rasa itu dah 1,000 lebih pun. Ataupun orang tak kisah pun. Ataupun orang dah tak declare lah kan. Sebab dia dah macam sesama biasa. So mungkin secara penuhnya tahun depan saya rasa mungkin ada yang dah grad, ataupun masih siapa yang ada bersisa tu. Yang ID19 tu kemungkinan tahun depan tu secara pasti insya-Allah, kecuali maut yang menentukan, face to face kot. Mungkin tahun depan kan. So tak ada lagi lah kita punya online kot. Lama dah kot. Dah lama sangat online ni. Kita dah ikut WHO lama dah kan. So saya rasa tahun depan tu dah full capacity lah kot. Okay. So sebab baru balik, mungkin ada yang jet lag lagi. So saya usik sikit-sikit je lah. Saya usik sikit-sikit je. Dia ni Great Connected. Masih sambungan lagi. Tak tahulah korang ingat ke tidak. Tak tahulah. Sebab dah rayakan kan. Dengar saya ke saya cakap seorang ni? Tak syok kan?
Terdengar.
Boleh.
Alhamdulillah. Dengar Itulah. So playtime finish. Tapi boleh sambung lagi raya. Tak masalah. Tunggu kelas kena proceed lah. Macam biasa kan. Macam itulah. Okay. As usual, attendance. Siapa yang tak attendance tak masuk tu nanti PM tepi lah lepas kelas. And then I already released the quiz 1, quiz 2 and the midterm test. Okay, midterm test. So you can see lah your midterm test result. I think most of you boleh score lah sebab soalan tu bapak senang, soalan 2 kan. Purposely itu dibuat begitu. Tapi we have given you all the critical, I mean the exercise. The exercise part, I think the difficult part we gave you already. But when it comes to the question, it's very easy kan. That's why saya rasa ramai lah yang score. Yang soalan 2 tu kebanyakannya boleh score secara cemerlang je lah. So saya harap teruskan kehidupan seperti biasa, tapi jangan overconfident lah untuk final exam. Saya tak apa langit tidak selalu cerah kan. Macam tu lah. Maksudnya it doesn't mean that kalau test semudah ini final pun macam tu lah. Tak semestinya lah kan. Mungkin ini adalah gula-gula kan. contoh tak cakap apa pun. So jangan lalai. Okay, jangan lalai dengan apa dengan result yang dapat ni. Mungkin rasa terbaik kan. Saya rasa over 15% tu ramai yang boleh dapat berbelas-belas lah. Over 15, which is congratulations. Tapi kena teruskan ke depan. We still have lots. Final exam, don't forget, final exam is 60%. Okay, final exam is 60%. So that's quite a lot of portions for the food assessment. And you have another 2 quiz remaining. Plus the lab still belum lagi kan deadline dia. Laboratory and the assignment. Okay, assignment I will give after the lab. After you submit the lab, then here comes the assignment lah. So I don't want you to get confused or get mixed with the assessment. So my target is to first finish the lab, everything. Then after you submit the lab, then we proceed next with the assignment. With hope that you can give the best lah. So that you are not really, mungkin lah subjek lain, you ditekan oleh subjek lain, saya tak nak lah ditekan oleh saya juga lah, macam tu lah. Boleh saya nak mancing kan, macam tu. Okay, boleh ke? Alamak, gatal hidung lah. Boleh Aziz, Syauqi? Boleh?
Ada doktor.
Ada masih intak Okay. Sekejap hidung saya gatal sikit. Susah. Kalau saya nak terbersin tu, saya akan tutup mic lah, kalau sempat lah. Okay. Until before hari raya kan. Before the hari raya, after the test. Okay, after the test there will be holiday. The weeks 8, last week 8. So we have finished until though the test until chapter 3, but we have finished until the design based on criteria. 3 criteria there is based on space, budget, and also the energy requirement or the energy yield. Okay, so we have finished. We have covered already based on design, based on roof space or land space. Second one is based on the design based on the budget. Okay, budget. Then the third one is based on the energy yield. Okay, energy yield, which is this is in the megawatt hours. That megawatt hours energy lah, energy target of that. Okay, then after we did all the calculation, then finally we asking you about the maximum numbers or minimum numbers of the modules that if you still remember lah. Finally you are going to get Nmax or Nmin. Nmin, minimum numbers of modules tu specific to the third one lah, based on the energy yield. Okay, based on energy yield. Sekejap, gambar saya macam stuck sikit tak syok lah.
Ya.
Oops. Saya tutup. Banyak nak buka. Dia pening je. Okay juga. Tak syok lah selakut. Okay. So then we calculate lah. We get the numbers of Nmax or minimum or Nmin of modules kan. So ni dapatlah modules berapa dia punya modules. Contohlah dapat kira-kira dapat 30 ke 32 ke whatever lah. But after you calculate based on the space, everything, budget, and then finally you take out the numbers of the modules that can be installed on that place based on that required criteria. Okay, so after that what's next? Okay, so means after you get the number of modules, so what should we do next? So this is what we're going to do. Okay, selection of inverter. Okay, by procedures ke? I'm talking about procedures ke? First of all, based on criteria, then we get the certain numbers. Then after that, we are going to choose the inverter. Whether you are given the choice to choose the inverter or the inverter is fixed, or by default you have to choose the inverter lah once you get the modules. Okay, number of modules. Okay, ini sangat singkat dan ringkas. So since the number of PV modules has been established, so based on the three criteria, the design based on the three criteria, then we get whether the maximum or the minimum numbers of modules. So the next step is to match the specification of PV array and inverter. Okay, so we are going to do the matching between the PV array and inverter. So we are going to play with the modules again, and also the inverter. Then we are going to align it. We try to find the best fitted configuration like that. Okay. But after we get we calculate the modules, we get the numbers of modules. So the range of suitable normal inverter power specification that is suited with the PV array is determined as, okay, this is what we what is the relationship. So the PV array, PV total of PV array, we get the numbers already. Actually, we get already the P array STC. Okay, we already get the P array STC, or we get the module and number of the modules. Okay, next step, okay, to choose the inverter, which type of inverter is suitable for our PV array. For example, I give you the example. Let's say we have 200 watt of module. Then after we calculate based on budget, something like that, then we get, for example, 20 modules. Okay, maximum numbers, we get 20 modules. So by default, for the P array STC, it's easy, and you just multiply 200 with 20, which is you're going to get 400 kilowatt. Okay, again, we choose some module that is rated with the 200 watts power, and then after we calculate and so on the space, whatever, then we get the 20 modules. Okay, we get 20 modules. So mean the total P array STC is equal to the the PMP STC multiplied with the number of modules, which is 200 multiplied with 20, you get 4,000. Yeah, Aziz, nama Aziz? Buka mic lah. Suspend tu. Okay. Alright. So we get 4 kilowatts. And then the range of suitable normal inverter power specification that is suited with the PV array is determined as 0.9 multiplied with P array STC between P nominal inverter, okay, P nominal inverter less than the 1 multiplied with P array STC. Okay. This P array STC will be based on the PV array. Remember, PV array, which is at this part, is DC. Okay, DC. Alright. Then, so this is the DC. For example, for this case, is 4 kilowatt. So 4 kilowatt. Same goes with this one, because P array STC we already calculate. Alamak. Sekejap saya nak tutup lah. Sebenarnya banyak. Dia heavy pula. Sekejap ya. Tutup application ni. Banyak sangat ni. Macam banyak sangat. Kan start lah. Alright. Okay. For this case also 4 kilowatt. Okay. So you just simply calculate lah. But parameter important here is 0.9 and 1.0 is the range of the from the PV array. Then we can select the appropriate inverter based on the nominal. Okay, nominal value for that inverter. Okay. Before this, I think the old what we call it, old version of the SEDA, the unrevised one, originally the value is 0.75 to 0.8 only. So this is the previous one. Okay, we use this kind of values. But now the most recent one is between 0.9 to 1. So what we are going to use now is 0.9 and 1. Okay, just follow exactly this equation lah. Okay, so this 4 kilowatt, for example, this one, saya padam ni takut confused. Okay, this one you're going to get 4,000 kilowatt lah. Okay, 4,000 kilowatt, and this is the, boleh kira sekejap 3600 ke? Ingat. Betul tak? 0.9 darab 4. 36 watt. Is it 100 watt? Jap, aku cakap seorang lah ni. Hello, Jamadin, okey ke?
Okey je Doktor.
Okey. Aku cakap seorang lah. Lama sangat kau ni mood raya lagi, kau tengah makan kuih raya tu. Aigo. Irfan okey Irfan? Muhammad Irfan?
Okey Doktor.
Alhamdulillah. Alhamdulillah. Okay, so between three means that we need to find the inverter, the suitable inverter within the range of 3,600 watt and 4,000 watt. Okay, 3,600 watt and 4,000 watt. Okay, so the nominal inverter that we are going to find it within this value lah is the best one. For example, if we get 4 kilowatt, so okay lah. If we get 3,800, so okay. If get 3,700, so okay. Okay, but the difference is this is written as a nominal inverter, nominal output power for the inverter. It's actually, I repeat, it will be based on the AC power. Ataupun kita panggil PAC. Ya ke PAC? Betul ke? Ataupun watt AC lah. Okay, dia lain sikit. The PRSTC is the DC one. But the P nominal inverter, nominal output power for the inverter, we are using the AC one. Okay, AC side. Sekejap, gambar saya keras. Tak pula. Tak syok lah sini. Tutup ya. Kacau. Terganggu betul. Ya. Dia tak syok. Tak ada buat apa lah. Sama gak. Lantak lah. Okay. Alright. So means that the value that we are going to refer here is not the DC power, but it's actually the AC power. Okay. I think maybe you get confused already, You don't understand. It's okay. I will show you the example of the inverter. Okay? Example of inverter. Yep. Okay. So this is the old brand. Now we are not using it anymore maybe. So Fronius brand. Okay. I just take from the previous example lah. Okay. So this is the technical data or the data sheet for the inverter brand Fronius. Okay, Fronius, whatever lah. Okay. And then here there's 3 model here. Jap. Kenapa hang? So here we have 3, IG15, IG20 and IG30. Okay, then we have the MPP voltage range, maximum input voltage. Tapi jangan tengok lagi. Okay, you see here. We are going to look, we are looking for the watt. Okay, we are looking for the watt. Okay. PV system output. And then what else? they have the maximum output power, they have the rated output. Okay, so there's value there. Okay, the P nominal inverter I told you, this value, sekejap tak keluar pula. Okay, this value is referring to the output data. Okay, output data means AC lah. So this one. Ni. Output data. Okay, output data. So we are looking for the wording nominal output, nominal AC, rated output, rated AC lah. Okay, this is the value. So rated output for this inverter is 1300. Okay, 1300 is P nominal inverter. Though jangan concern sangat lah. Don't take too seriously with the serial number. But this is it refer to the maximum value. But the value that we're going to look is on the rated output. Okay, rated output. So this example for the Fronius. Okay, let's see ada brand. Ni lagi mengelirukan. Okay, so this is the example of the brand IBC. Okay, IBC brand, IBC Solar, from the IBC Solar. Then, okay, you see here. Interesting. This is very interesting. Okay. Let's say we go for the 10,000 TL brand. I mean, with the series number of 10,000 TL, then you see there will be two value of nominal. Nominal. They have the nominal power DC. They have the maximum PV power. They have the nominal power AC, and they has also the maximum AC power. So my question, what will the nominal power for this inverter? Which value that we are going to take? Hafizah, Ali. Ya. Hello? Boleh dengar saya? Ke saya cakap seorang?
Boleh dengar.
Boleh dengar, Alhamdulillah.
Dengar.
Mana Hafizah Ali? Senyap pula. Fatin Adawiyah. Makan raya? Ayuh. Syahmi Hafiz.
Yes, sir.
Ada pun. Okay. Which value that we are going to take as the nominal power for the inverter? Value yang mana? Untuk yang 10,000 ni. 10,000 ni. Mana satu?
$10,300 enggak?
10,300. Salah. Satu tanah ayat je. Dah. Tanah lain tak. Siapa? Izzat Imran.
Yes, sir.
Bila mana kita ambil
Beda untuk apa dia?
Sudah. Dulu tak apa tanya kepada dia. Ni. Nominal ni. Ni P nominal inverter ni.
Okay.
Mana? Untuk 10,000 TL. Lama nak fikir ke?
$700 tu. 700.
Kan, itu nominal voltage. Kita nak power. So power tu patut ke atas lah. Yang bawah tu, ni voltage. Kita nak power.
10,000 AC tu ke?
10,000
AC.
10,000 AC. Yang mana ni? Nak nominal ke maksimum mana tu?
Nominal tu.
Nominal.
Okay.
Power AC.
Yes. Kita ambil nominal AC. Okay. Maksudnya, we are going to take the value for the AC. It's referring to the AC. The nominal power for the inverter refers to the output power of the inverter. Output means AC lah. Input DC. Okay? Input from PV array is the DC. Output from the inverter will be AC. Sebab inverter kan AC. So, we are looking for the value of the nominal AC power, rated AC power, rated output. Rated output, rated AC, that's the value that we're going to take. Okay? Because after this, in your assignment and so on, when you are going to choose your own inverter, based on your design, ada yang based on the space, ada yang based on the energy yield, ada yang will be based on the budget, you are going to select the most appropriate inverter. So when you are choosing that, you have to make sure that you are going to take the AC. We are going to referring to the AC output. Okay? Don't take the DC because the value sometimes by luck you can get both value are the same, but most cases I will say that the output one is lesser than the input one. Tengok sini kan. Ini contohnya 10,300, output is 10,000 only. Most cases like that lah, 12,000 tapi the output is only 10,000. So we are going to look at the maximum power that we are going to fit to the TMB, which is the output one lah. Okay, remember? Boleh? Amirul?
Boleh tu.
Boleh, Naufal? Boleh, Naufal? Senyap lah dia.
Boleh lah dia.
Alhamdulillah. Okay. Alright. What about this? Tak apa. Tanya Farhana.
Yes, sir.
What is the nominal power for this inverter? Which value that we are going to take? Ni banyak sikit. Pilihan dia. Tak tahu yang mana satu. Mana? Cepat.
Yang output.
Output.
Maximum output power.
Mana? Maximum output power ni?
AC bawah.
Yang ni? Maximum output power ni Ui, salah.
Ya.
Kita tak ambil maksimum. Kita akan ambil
Ke rated output power.
rated lah. Aku dah cover tadi. Boleh mulut ni. Rated ataupun nominal lah.
Okay.
Kita ambil pada rated ni. Rated output power ni. Tapi betul lah, kau teka tu betul dah dekat bahagian AC, KAC, and then we are going to look for the rated output power. Remember, rated output power atau nominal output power. Don't look at the maximum value. Don't refer that maximum value. We don't need that. We just looking for the nominal or the rated. So untuk case ni yang ini is 12 kilowatt. Okay, 12 kilowatt. That's why the model, the series number also showing the 12K kan. Kat sini ada dalam ni 12K. Yang ni 15K. 17K. Mostly macam tu lah. Tapi yang Fronius ni dia lain sikit. Fronius ni rated output dia adalah 1300. Tapi IG15, tapi don't don't take it too seriously about the serial number. It's the clue, sometimes different. Okay, untuk kes ni dia different. 15 dekat sini. Tapi rated power sebenarnya bukan 15. 15 is the maximum one. So ini adalah 1300. Untuk kes Fronius IG15, rated output power is the 1300 watt. Okay. And for this case is 12. Okay, 12 kilowatt, 15 kilowatt, 70 kilowatt. So we are looking for the rated output side AC. Okay, rated power output ataupun AC. Okay, begitu. Any question? Sehingga sini belum lagi ni baru introduksi.
No.
Tak ada. Okay. Let's say you have a lot of choice. Okay, we have a lot of choice inverter. For example, we need to find the inverter with the nominal value of between 3600 watt to 4000 watt. Unfortunately, we don't have the inverter with the rated power between this range. What we get, for example, 3500. This is just example. 3500, 3000 watt, and 5, and then we get 42, and then we get maybe 7 kilowatt now. Okay. For example, you have only these 6 inverters only. So you need to choose the most appropriate one. So which one of these 6 item of inverter you can choose? Which one is the most suitable? Faizuddin.
Ya, Doktor.
Yang mana antara 6 ni, mana menjadi pilihan?
Yang 4,000 ke, Doktor? Yang bawah-bawah.
Yang mana, ini ke? Ini?
4,000
4,200 silap. Tulisan buruk biasa lah.
4,200.
Ini 7,000, ini 4,500. Ini 5,000. Dibersambung-sambung pula tulisan ni. Ni ada 3,500. Mana ni? Ni 3,500, ini ada 3,000. So yang mana yang kita kena pilih? Kau teka. Penat pula aku tu.
4,200.
Apa?
4,200.
4,200. Why?
4,200.
Why? Teka betul. Kenapa tak?
Because in the range.
Kenapa tak 3,000? Range dia 4,000. Range 4,000 maximum. Minimum 36. Kenapa tak pilih 35? Kenapa tak pilih 3,500? Mana ni? Mana ni? Kenapa tak pilih 3,500 ni? Okay, kau pilih ni kan, 4,200. Kenapa tak?
Itu bawah.
Ulang balik?
Sebab dia kurang lagi tu.
Okay, dia kurang lagi. Sebab tu kau tak pilih?
Sebab yang tu kurang tu.
So tak pilih lah?
Tak pilih lah. Pilih yang 4,200 lah. Sebab tak ada yang dalam range dia kan. Jadi kita pilih yang tinggi, lebih tinggi dari dia tu.
Ni 4,500 ada ni? Ni?
Macam mana tu?
4.5 ada tak?
Yang paling dekat.
Mana yang paling dekat?
Lagi jauh sikit.
Okay. I got your point. Okay, tak apa. Tanya orang lain sikit. Thank you Pak Izin. Tanya orang lain. Siapa tadi aku panggil senyap ni? Fatin ada dah, Fatin Adawiyah. Tak ada. Ada pun. Mana? Nak pilih mana ni inverter?
Apa dia?
Kita nak pilih inverter. Let's say range 3.6 kilowatt to 4 kilowatt. Okay. Tapi kita ada 6 choice ni. 1, 2, 3, 4, 5, 6. Choice yang ada ni 3,500. Lepas tu ada 4,500. 4,200. Which is tak ada dalam range ni. Tak ada dalam range ni lah. Maksudnya tak ada dalam range 3.6 kilowatt to 4 kilowatt. Tak ada. It's not in the range. So, tapi kita we still need to choose the inverter. So, which inverter is the most appropriate one? Tadi Faizuddin tadi cakap 4,200 bukan 3,500. Dia kata macam tu lah. Dan bukan juga 4,500. Dia kata 4,200 lah. So awak rasa pilih mana? 7,000 kah? 5,000 kah?
3,500 kot.
3,500. Sebab?
Dia dekat dengan 3,600.
Okay, dia dekat dengan 3,600. So kalau berbanding dengan 4,200 tu dia lebih dekat lah. Macam tu Okay. 4,200 tu dia lebih 200. Kali ini dia kurang je 100. Okay. Ada point di situ. Kita tanya seorang lagi supaya lebih adil dan sama. Lee Yao Meng. Lee Yao Meng. Lee Yao Meng beraya juga. You. Ganesh.
Yes, sir.
Ingat lagi juga. Aduh. Okay. Okay. Which inverter is the most suitable for this case? Fatin tadi cakap 3,500. Faizuddin cakap 4,200. So which one is better for you?
I'm not so sure, sir. Maybe 4,200.
Why? Why not 3,500?
Because we need 4 kilowatt of inverter. So the maximum that the inverter can produce is 4.2. If we choose 3.5 means the maximum it can produce is just 3.5 kilowatt.
Okay.
So I think 4.2 is the manage.
Okay tu. Betul tu. Okay, acceptable. Alright. So this is the reason. Because our target is to get the maximum power as we can. Okay. If we choose 4,200, confirmly, if in the very good weather, very good condition, we can get maximum 4,200. Why our range is 4,000? Which means we can get more than that, 4,000. But if we choose, like Fatin punya pilihan, walaupun mungkin dia main teka je, kan? 3,500 it's actually close to the 3,600. Tapi by default, kalau if we have to choose which one is the most appropriate one, we are not going to choose the 3,500. But if we have in the range 3,700, definitely we are going to use the 3,700. No negotiation, is fixed. But if it's not in the range, then we are going to find the slightly higher than the highest value. This one 4,000. If available 4,200, we choose 4,200. If it's not available, if the next one is the 4,500, so we choose 4,500. Okay? We are not going to choose lesser than the 3,600 Okay, because the maximum one it can be pulled until 3.5 kilowatt only. So it's a waste Dia tak dapat maximum drive lagi. Walaupun very close to the range. If it's not in the range If in the range, then tak ada issue. No issues at all. We just choose that. As soon as in the range, we don't care. For example, kita ada 3,600, another one is 4,100. We choose the 3.6 kilowatt because it's in the range. Okay. Alright. Ini bau sini. Pergi jauh lagi. Okay. Any question? Bau satu slide.
No.
Okay, saya proceed kejap Alamak. Baru nak berjanji habis awal. Semua janji di capati. Okay. Saya cuba sedaya mungkin. Alright. Ni kosong. Okay. Next, after we choose the inverter, then we are going to do the alignment, or we call that as the inverter PV array matching. We are going to do the voltage matching actually. Okay. We are going to match with the voltage. Okay, so after we choose the inverter, settle, choose the inverter, then we proceed what we should do next. It's not end by only design, choose inverter, finish. No, but the question can be until choose inverter, or maybe full, whatever lah. Okay, assignment will start from 0 until finish. Okay, inverter PV array matching. Okay, it is important to ensure that the array is matched to the inverter's input specification. So PV array, the output from the PV array must match with this input specification of the inverter. So output PV array kena match dengan input inverter input tu. Okay, so that all system components are appropriately sized to suit the site specific condition. Inverter should be chosen so that the maximum power output from the design PV array matches the inverter's maximum array power input. This is what happen if we choose the we call that underestimate or the underperform. If we choose the small type inverter, we cannot maximize the PV output that we get. PV array we get maximum power, but because we are mistakenly choose the wrong inverter, maybe the size is too small, so it's a waste. The exceeded power, the excessive power will not going to be exported to the TMB because the inverter is limited there. But if we choose this too bigger of the too big size for the inverter, so it's not efficient. Okay, it's not efficient because maybe sometimes we turn on, turn off. If we really don't care about the input voltage and so on, so it's not going to work it appropriately and efficiently. That's why we need to choose the appropriate inverter. Okay, so we also want to avoid oversizing of the inverter, as it will reduce the inverter operating efficiency. See, if we too much bigger, the size too much, it totally reduce the inverter efficiency, and hence reduce overall power output. Designer needs to ensure that the inverter and PV array match in terms of voltage, current, and power to ensure a safe and efficient PV system. Okay. So matching voltage specification, calculate the expected voltage output. Calculate the expected voltage output of the array. In the same concept of the chapter 3, corrected output or the real operating condition, but slightly different. Okay, it's almost close to that, but we are going to use the same equation. Okay, by the change of cell temperature. Okay. Calculate the expected voltage output of the PV array that is affected by the change of cell temperature. Still the same, temperature coefficient and so on. Datasheet generally provide at least one temperature coefficient for voltage, a specific rating that describe the effect of temperature of the cell. Itu maksudnya the value. Okay, we are going to play with the this opposite voltage and this temperature coefficient. Okay. So usually expressed in percentage or volts in per degree, as we have studied before lah. Okay, so that value lah. So two things we are going to look into it. One is the open circuit voltage with their respective temperature coefficient, and then the one is the VMP. Okay, the value for the VMP also with its respective temperature coefficient. For this case, VOC, it's okay, I will explain later. But these two values, we are going to play it seriously, and we have to be more focused for these two values. Okay, VMP and the VOC. Alright. Okay. So first of all, we need to calculate the maximum voltage, or we call that as it's not really the real operating condition. Okay, the real operating condition, the difference between the previous one, with the ROC that we learned before in the chapter 3, that's written only T cell. Remember? T T-cell. Ingat kan? T-ambient yang korang suka nak tu. T-ambient NOCT minus 20/800 multiplied with G. So this is the T-cell cell temperature. You calculate the cell temperature based on given ambient temperature and also the solar irradiance given and also the NOCT values. But this time, for the Greek connotation, is different. Sorry. The value for the T cell here is written as the T cell minimum. T cell minimum. And the value is fixed. You are not going to calculate the cell temperature in this case because we have the value fixed already. Okay. That's why it's written as the calculating the maximum voltage. So we are expecting the maximum voltage means the most perform condition. Okay. The module maximum voltage is present at the minimum cell temperature, which in this case is 20 degrees C. Okay. I repeat. We are looking for the maximum voltage. Maximum voltage is when the module performs very well. Okay. Perform very well during low temperature or high temperature. Asif. The module tu will perform very well at low temperature ke high temperature? Which one?
Low temperature.
Why low temperature? Because it written there. Low temperature. Kita belajar kan temperature coefficient tu dia akan when the temperature is getting higher, so the voltage slightly start significantly decrease kan. So that's the reason. So the modules will perform very well during the low temperature condition. That's why the T cell minimum is fixed. I repeat, fixed. 20 degrees C is fixed value for the Malaysian case. Okay? So this 20 degrees C will be replaced here. Means you are not going to calculate any more cell temperature nan cara blah 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 here. Okay, no need to calculate that because the value is fixed for the case of calculating the maximum voltage based on the VOC. Dia ada VMP juga. First of all, kita pergi dulu. First step ni, calculating maximum voltage based on the VOC where the T cell minimum is 20 degrees C. Okay? It is therefore important to use the open circuit voltage value. So here we are going to use the VOC value, same like before maybe, and adjust this figure according to the temperature coefficient when calculating the maximum voltage. Okay, same like before, the equation, the different. If the temperature coefficient of VOC is given in percentage as usual, yes, you have multiply M1 here. Same like before. If the temperature coefficient for the VOC is given in absolute value, no need for the multiply M1, only plus here. Okay, this sepatutnya you shouldn't get confused anymore. Because you already expert, because you score very well in your test kan, written test kan. So I assume no brother or sister will make mistake. Okay, so we calculate as usual. V max OC. It looks like the ROC one. It's almost the same, but here we define as the maximum voltage based on the VOC. That's why we read max OC. Based on VMP, kita tulis max MP. Okay, but for this case, max OC. So VOC STC multiply with 1, and this is the temperature coefficient for the VOC if given the percentage. And this value is replaced with the 20, and the TSTC value, how much is it? 25. Oh, sir, become minus. Who cares about the minus? Definitely, this product will become minus value, minus 5, but multiply with the temperature coefficient. Okay, you're going to multiply with the temperature coefficient for VOC, and then you get the plus value. Then you get 1 plus something lah, because this is the minus value and this is also minus. Then minus get plus. That's why the maximum voltage will be higher than the VOC STC. Boleh? Means that this value should be more than the VOC STC. Different with the previous one. previous one, we calculate ROC kan. Remember? Apa tu? Open circuit voltage. Real operating condition of the open circuit voltage kan. Yang korang seronok sangat buat tu. Yang dapat skor tu kan. VOC ROC kan. Okay, this one kan you get will be lesser than the VOC STC. Why? Because the T cell tu basically it goes until 50, 60 kan, 65. Then this part will become plus kan. That's why dia akan minus remain, dia tolak. But this case, this one 20 minus 25. Nampak ni? Aku cakap ni. You will get minus value. Minus with the minus, then you get plus. That's why the maximum, the Vmax OC must be higher than the VOC STC. If you get lesser, you're wrong. Boleh? Muhammad Yusuf. Boleh ke Muhammad Yusuf? Mana Muhammad Yusuf ni? Ramai betul cuti ni. Hafizah Ali tak berhati tadi dia senyap. Hafizah Ali. Macam mana? Okay. Boleh kan? Boleh kan? Make sure the value for the Vmax OC must be bigger than VOC STC. Okay, kalau you get lesser tu kecil, silap lah. Okay, dia kata silap. Right. Okay, this for the first case is calculating maximum voltage based on the VOC. Okay, based on the VOC. Alright. What's next? Okay. Second. Saya rasa saya habis ni saya stop lah. Ada 3. Okay, 3 values. Okay, next is calculating maximum voltage also, but this time will be based on the VMP. Okay, VMP. Just now, we based on the VOC. This time, we are going to be based on the VMP. So, very easy, same thought. Okay, VMP is present at the minimum cell temperature, is still the same, 20 degrees C. Okay, 20 degrees C, same, means that T cell minimum is 20 degrees C. Okay, and this is the 25 degrees C. So, still the same, you are going to get the minus 5 here. Okay, same, no different. Therefore, important to use the maximum power voltage VMP. So, the value here is different. It's the VMP STC and the temperature coefficient for the VMP. Okay. This one is Vmax MP. Just now we get Vmax OC. So, OC, and this one also temperature coefficient for VOC. Now, temperature coefficient for VMP. You have to use the VMP one. Temperature coefficient for the VMP one, not the VOC one. But there's cases where you can take also the value for VOC, but after several consideration. But first of all, you need to look for the temperature coefficient for the VMP, which is some datasheet, they are not given that value sometimes. Okay, I think most cases also sometimes they don't give. They give only PMP, they give VOC, but they don't give the VMP lah. Okay. Alright. I hold here. Important thing is VMP value, but the T cell minimum is still the same 20 degrees C because we are looking for we calculate the maximum voltage. So Vmax, the temperature is 20 degrees C. For both cases, Vmax OC and Vmax MP are using the value of the 20 degrees C. Okay? Right. And don't you have to make sure that you have the value temperature coefficient for the VMP. Remember, Okay. Alright. Next, the third one. Okay, the third one is to calculate the minimum voltage. Calculating the minimum voltage will be based on the VMP also. Okay, will be based on the VMP. Okay, It will be based on the VMP, but with slightly different. The modus minimum voltage will occur when the set is the hottest. It's hottest, which is highest temperature. Okay? At a set temperature of 75 degrees C. Who decide that? This is the SEDA. Based on the data for Malaysia case, 75 degrees C is the T-max, T-cell max. It's fixed already, 75. Don't ask me why 75, 180. Based on the accumulated data, I think the Malaysia cases data, the MET, also the SEDA, they already observed for several years. I think the highest temperature ever recorded around approximately is 75 degrees C. So we just follow it. Okay? 75 degrees C. Here it written T cell max, but the value is the minimum one. That's why it becomes V min MP. Just now, V max MP, but temperature 20 degrees C. But this time, V min MP temperature is 75 degrees C. And this remain 25 degrees C, then I think the total you're going to get 50, which is the plus value. When the plus value here, because the VMP, the temperature coefficient of VMP is minus value, then it will drop. So, lastly, the value must be lower than the VMP STC. If you get higher, you make mistake. Okay? Boleh ke?
Betul.
Ya. Teruskan.
Yang ni untuk VOC dia ada kan?
Apa dia? Okay. Untuk minimum voltage, no VOC. Dia untuk maksimum saja
Okay.
kita pakai VOC. So ada 3 lah. Hanya ada 3 item saja. Okay. Maximum voltage based on VOC. Maximum voltage based on VMP. Next, minimum voltage. Minimum voltage ni memang based on the VMP. But the T cell max is different now. 75 degrees C. Remain the same. You have to use the temperature coefficient for VMP. Okay, for VMP. Not the VOC. Okay. Boleh? Sebelum saya pergi masuk slide lagi. Okay. Approximating temperature coefficient. Okay. If the temperature coefficient for maximum power voltage, tadi saya highlight banyak kali kan. Ni. Because in calculating the maximum voltage based on VMP and calculating the minimum voltage which is based on VMP also, need the value of temperature coefficient for maximum power voltage, which is the VMP ni. Okay, VMP. But like I told you, not all the datasheet or manufacturers give all the value, including the temperature coefficient for the VMP. It's very rare. Not rare lah. Actually, it's not mandatory for them to put. Usually they put VOC, ISC and PMP. Okay, worst case they put VOC and ISC. Sometimes PMP also doesn't give. Okay, but for this case, because we need the VMP one, so if the temperature coefficient, the what call the gamma, the gamma VMP is not given, dia macam biasa lah, dia datang dia punya assumption. Okay, if it's not given, the temperature coefficient for maximum power in the unit of percentage should be used. Okay, VMP is not given, we don't use VOC, we use PMP instead of VOC. Kan pelik, dia pelik di situ kan. But with condition, the value for the PMP must be in the percentage, because remember kan, VMP, IMP semua tu kan, VMP, PMP is totally correlate to each other, very close. Then we can use the PMP one because it's the same percentage, will be not really different compared to the current one. So we can use the PMP in percentage. Okay, it must be in percentage. If they're given you in the absolute value, okay. If the gamma PMP value is given in watt over degree C, because it given in absolute value, it should be converted it should be converted to the percentage. You see, so this the thing that you need to be very careful. Okay, don't use the voltage. If they give it in millivolt, it's wrong for you to use 100% of the values. Totally wrong. You need to convert it first in the percentage. But if it is already given in the value of percentage, okay, just use it. Okay. If it's not given, then you need to convert it to become the percentage. How to do that? Like this, only this. The value for the PMP in absolute value over the PMP value. PMP is this here. For example, this module is 100 watt. So you divide with the 100 watt, multiply with 100, then you're going to get the percentage in the percentage one. But eventually you need to over 100 also one. But you can get the percentage value. With this case, you can get the percentage DDC lah. Originally, that comes from the watts, maybe watts. Okay, watts. Then you can convert to the percentage. Then that percentage value you can just put simply in here lah to calculate the Vmin MP, VMP, STC. Same goes with the Vmax MP also. I mean for the case of MP lah, MP. Bukan member of parliament, maximum power. Okay. Alright. In case, ni ada exit route lagi. Last call. In case the apa ni panggil alpha, beta. Okay, the beta, bukan beta, ni gamma kot. The gamma PB is not given also, okay, use VOC. Okay, this is last resort lah. If the value is given, if VMP is given, you go for the value for PMP is different. If it's the same, you are lucky lah. If different, then wrong lah. Totally wrong. Memang saya akan salahkan. Kalau VMP is given. VMP is not given, next step is PMP. Remember priority, first priority VMP. If not given, jump to the PMP. Percentage, remember. If it's not given, finally go for the VOC lah. VOC ni is okay, just use. If you want to use the absolute value, okay. If percentage value, also okay. Okay? Alright. So this is the priority list. First of all, you need to look for this. Okay, this one. If it's not given, go for the PMP. Basically, the PMP one is given. So you can simply take it, the value percentage exactly like that. Boleh? So kita kak. Ain Izati. Ain Izati. Oh, senyap. Ada.
Ya, doktor.
Macam mana, okey ke? Boleh ke? Ada soalan?
Tak ada.
Tak ada. Kau tengah makan kuih raya. Bukannya aku tanya soalan je kan. Tak ada soalan betul Tanya ni.
Tak ada.
Tak ada Okey. Siti Fadilah.
Yes, sir.
Ada soalan ke? Boleh faham ke apa maksud saya cerita ni? Kau tengah makan kuih raya atau makan lemang lagi?
Tak ada.
Boleh. Setakat ni tak ada lagi lah.
Tak ada lagi.
Okey, baik. Siapa? Owi. Owi.
Ya, doktor.
Bagus Owi ni. Dia cepat balas. Okey, ada apa soalan tak? Boleh faham tak? 3 benda ni.
Boleh. Saya ada soalan.
Boleh Tanya soalan kan? Kalau boleh saya tanya soalan terus. Saya try satu soalan If okay. Owi, masih lagi Owi.
Ya, doktor.
Okay. Sebab dah faham tadi kan kita soalan. Let's say lah the value for the PMP is not given. You want to calculate. Kalau tak bagi PMP tu nak buat macam mana? Data PMP tu tak bagi.
Data VMP ke, doktor?
Saya tanya kalau PMP tu tak bagi.
Oh, PMP. Gamma VOC.
Gamma VOC. Tak.
Betul kan doktor?
Kalau VMP dia bagi, pakai VMP lah. Tak ada. Maksudnya,
Oh, PMP bagi.
dia yang penting kena ada VMP kan. Tak ada VMP baru bagi PMP. Kalau ada VMP dia tak bagi PMP pun tak ada lah. Itu pasal lah kan. Betul tak? Tapi saya faham lah, maksudnya kalau VMP punya part tak ada, VMP pun tak ada, ambil VOC. Ya, betul tu. Okey dah tu, tidur bagus. Alright. Masuk sikit tak? Masuk sikit kan janji basuh ni kan. Baiklah. Nanti kita masukkan laut pula. Okey, any question? Ni masuk besok. Ya. No, ingatkan ada soalan. Yang lain ada soalan tak? Fakur Izwan ke? Syahidah ke? Ada soalan tak Syahidah?
Tak ada sir.
Tak ada lah. Boleh aku nak panggil. Daniel. Ada soalan tak Daniel? Ada soalan tak?
Belum ada lagi.
Okey. Seorang lagi. Ashraf. Ada soalan tak?
Tak ada doktor. Okey.
Takkannya boleh makan lagi Bolehlah sama bergaya balik. Okay, you can check your I already upload the answers in the kalam. Saya dah buka balik. So yang boleh tengok lah yang mana yang salah, yang mana yang betul semua tu kan. Begitulah. Okay. Alright, if no question, so we end here. We continue on Wednesday as usual. Okay. Selamat menyambut hari raya lagi. Dan siapa yang berpuasa 6 tu, selamat berpuasa lagi sekali. Okay, 6 hari. Alright, terima kasih.